In this presentations, we are going to discuss about Peephole optimization in code optimizations. It is the most familiar and very important optimization technique. So in this Peephole optimization techniques, the unwanted codes are removed where you have to handle the instructions very carefully and the selections and registers allocations of the code that to be handled in very strongly, and they generate the navy code and then improve the quality of the target code by applying the optimizing transformations to the target program. A simple but effective techniques for logically improving the target code is a peephole optimizations, which is done by examining a sliding window of a target instructions. And the peephole optimizations can also be applied directly after intermediate code generations to improve the intermediate representations. Actually, the characteristics of peephole optimizations is in it have the better improvement in the target code, and repeated passes over the target codes are necessary to get the maximum benefit. The examples program transformations, those are the characteristics of the peephole optimizations are redundant instruction selection, flow of control optimizations, algebraic simplifications, use of machine items. So here the redundant instructions. Actually, basically the peephole optimization is used for reduce the redundant instructions. So consider a target code is LDA, R naught, then ST R naught, A. So here already in the load statements the content A is available in R naught. So no need of this store statement here. So this is acts as a redundant instructions, because the content of A is already available in the R naught and A also. So no need of store the content of R naught into A. The next one is elimination of unreachable codes. Some codes are cannot be reached. That is a best example. If we check if sum is 0, then execute that. But before that, we define sum is equal to 5 plus some variable, that's an average. So always the sum must be greater than 5. So in this stage we have to compare if sum is equal to 0, so that is no need. Okay, so the best example for debugging a purpose, a large program may have within it certain codes fragment that are exactly only if it available debug is equal to 1. So here consider the debug is defined by 0 by using the define statement. So but in this we have one if conditions, if debug, print that debug information. So here no need of if statement, because already we defined debug is 0. So in any case it does not meet debug is a true value, it is any time it is a 0. So no need of this line. So here this if statement is an unreachable code, it cannot be reached in any time. Next, flow of control optimizations. So in this flow of control optimizations, so consider, so one go to statement, it move to the one locations that's in that we defined by the label L1. So L1 has go to of L2. So then the L2 has some definitions. So instead of this 3 line we can write the go to of L2 directly. Okay, so no need of write go to of L1 here. L1 has a definition go to of L2. So again we define that statement. So in this we directly we can write go to of L2 in the line of the go to of L1. So next one is algebraic simplifications. That means if we add any 0 to the any number, that number. So no need of write x is equal to x plus 0. At the same time, if we multiply 1 with any number, that number. So no need of that kind of statements. So that is an algebraic simplifications. And the redundant strength. So here we have to minimize the strength of the expressions by, if we use a power symbols. So instead of power symbols we can use star. So how you can explain, consider x power 2. So here the power has a more precedence and more complexity in these executions. So instead of x power 2 we can write x star x. So that doesn't reduce the strength of the instructions. The last one is the use of the machine items. So here machine items is, if we want to increment any register's value or any variable, so for that we write increment INRC directly. So actually if we write x is equal to x plus 1, so that make 3 address code, and the target code is also 3 in codes, so that cost to be high. So instead of these 3 codes we can write simply one assembly code, that is an increment statements. That's all. Thank you.